In this video, we are going to be comparing fractions that have the same denominator. What does that mean? If a fraction has the same denominator. There are two parts of a fraction. We have a top part and our bottom part. The top part is called our numerator, and the bottom part is our denominator. And the way I tell students to remember denominator is there's a D for down. So the denominator tells us, do you remember what it tells us about the whole? The denominator tells us the total number of equal parts. So this is the total number of equal parts. Okay, my total number of equal parts for this whole is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this whole is split into 10 equal parts. Now this particular fraction has a few of them shaded in, and we'll fill out what the numerator is for each of our different wholes. Here is another strip, and as you can see, it is the same size whole split into the same number of parts. Therefore, the denominator is the same because it has the same number of total equal parts. But each of these are going to have a different numerator because the numerator tells us the number of shaded or selected parts. Shaded, selected parts. And for our example here, these are shaded. So that number is going to change depending on the number of parts that are shaded or selected. So let's classify or figure out which each of these parts, what fractional part is shown on each of these strips. So we know that all of them have the same denominator. They're all split into 10 equal parts. Therefore, our denominator is 10. And so then we're going to count the number of parts that are shaded. 1, 2, 3, 4, 5, 6 are shaded for our top one. And all but 1 are shaded for our second one. We know there's 10, so 10 minus 1 is 9. And our third one, we have just 3 shaded in. So the value for my first whole is 6/10, second whole is 9/10, and the third whole is 3/10. So now we're going to compare them. They all have the 10 equal parts. That means that every single one of these equal parts, they're all the same size because each of these wholes are the same size. So now which one takes up more space? Which one is the biggest fraction? So if we look at these, the first one takes up all this space until we get to here. So that's how much space is taken up of that whole. Our next one has all of this space taken up until we get to there. And this one only has that much. Now, since all the parts are the same size, the denominators are the same, whatever numerator is largest, that means that's the largest fraction. But the only reason that works is because the denominators are the same. So same size denominators, denominator. If the denominators are the same size, the larger the numerator, the fraction. So when the denominators are the same, the larger the numerator, the larger the fraction.